Hey, welcome for the last session. This session is just a talk and a panel. The talk is from Daven from US Signal, comparing our beloved CloudStack to other hypervisors. Take it away, Daven.
Thank you very much. Welcome, everybody. Thanks for being here. Thanks for coming to Madrid. For those of you who are not super local like myself, for those of you that are local, thank you as well, but a little bit less, right? I flew a lot farther than you did. So want to thank Shape Blue and Apache, obviously, for the product that I'll be talking about, for having us here, inviting us to speak, and obviously thank the attendees as well. Today, I will be evaluating open cloud against other hypervisors. And one thing not included in the title, we're also going to be stacking it up against a lot of the hyperscalers as well. So that's just like a little bonus that you didn't know about. First, myself. By the way, if you need help taking a picture of somebody and making it look like they're bald, let me know, and I will get you with our marketing team and get headshots done for you. So my name is Daven Winans. I'm the Vice President of Engineering and Innovation at US Signal. I've been in the industry for about 15 years, and all those bullet points up there are actually just my time with US Signal specifically. Before US Signal and before the service provider space, I actually came from the healthcare vertical specifically. That's where I started my IT career. Since I've been at US Signal, I have run all of these teams that are up here. I often joke that I've now managed, as of 3 or 4 months ago, every technical team at US Signal at some point in time. I started in our managed services and then moved into professional services. And then basically every successive bullet point, I just kept the previous bullet point and kept adding them to my fold. So currently, I actually run our cloud engineering, data engineering, transport engineering, innovation, R&D, and modern infrastructure teams at US Signal. One thing I've found, both with what I do for a career and also what I'm passionate about outside of work, which happens to be cars, is that data is really important. So whether you're measuring P&L, MTTR, time to answer, or building a new cloud environment or building an engine, data is kind of paramount to all of those things. So that's the one critical chain throughout me as a person, is that I love data. Assuming you do here as well, since you're here to talk about performance specifically. A little bit about US Signal. So we are a data services provider, data center services provider, founded in 2001, based in Grand Rapids, Michigan. My lovely boss did the keynote this morning. He's our chief operating officer. We've got 16 national data centers now, dedicated pre- and post-sales architectural support, 24/7 staff, TOC, or Technical Operational Center. And we sell ourselves as a network-powered cloud and data protection solutions provider. And you'll see why a little bit on the next slide, why we start with the network-powered portion of that when we're talking about ourselves. So we have the largest fully deployed and privately owned network in the Midwest as well. So kind of the company timeline, I'll try to hug the wall here as much as possible. We started in network specifically, network and co-location in 2001, and kind of added network services up until about a decade ago, 2011 or so, when we launched our cloud product, which was VMware-based. From then on, we've been kind of adding on data protection services, security services, and really not doing anything exceptionally innovative, I would say, up until maybe the last 5 years or so, where we really doubled down on the data protection expansion, a fair amount of M&A from a data center perspective, from acquiring additional service provider perspective, and then obviously our launch of Open Cloud, which is the CloudStack-based cloud that I'm here to talk about today. So 2025, we've got a lot more stuff that we'll be coming to the market with that I'm sure you'll hear about if you follow us at all. This is a look at our footprint. So we've got 9,500 miles. I'm sorry, I did not convert this into kilometers or meters or anything that you guys will understand. But 2,500 miles of fiber across the United States, with additions currently in the work. Fully protected core distribution edge networks, private access to the hyperscalers, and you can see some information about our data center locations, our current open cloud, which is the CloudStack pods, and then our traditional cloud pods. Dotted line is future network connectivity to some new data centers that we're growing into currently. Solid yellow line is our current fiber footprint. Technology trends. So this is kind of a call out to John's presentation this morning, and I know our VP of product will be talking about it a little bit tomorrow as well. Kind of what we see going on, right? So VMware is kind of the go-to virtualization platform and has been for quite some time. Obviously, with the Broadcom acquisition, there's been a lot of heartburn in the community in regards to what they're doing and how they're going about it, right? So at least 20% of current VMware customers will look to transition to a new platform going into 2025, and that is sourced from a Forrester article. And then hyperscalers. So hyperscalers really have mastered the consumption model and excel at reach, scalability, and service integration. And there's a large-scale repatriation kind of already started that we alluded to a little bit this morning from public cloud for better economics and service level agreements. So that's kind of what we see going on right now and why we decided to come to the market with an open source solution right now specifically. So why create open cloud? We desired a solution that would deliver more predictability in pricing. So that first bullet point is really around the cost, right? So we, as a service provider and for our customer base, believe that it's kind of, it is not fruitful to work with a vendor where that vendor has so much control over your model and your price that you deliver to your customer, right? They can really mess up your business at a whim if they decide to, like what we saw happen this year. We wanted to deliver a true cloud experience instead of another virtualization option. I've heard a few people today and a few of the talks talk about virtualization versus cloud and those two things being pretty fundamentally different. And then we wanted a consumption-based model in the market that gave a cloud feel. So we've been doing, usage-based products for quite some time now. But in terms of a true consumption-based model where you really have the flexibility as a customer to consume a lot or consume a little and fluctuate, throughout the day even, and then be charged for that specifically to give that hyperscale feel, right, that some of the customers really are attracted to that we talked to. But most importantly, we wanted something customers would buy, right? I probably wouldn't be doing my job very well if I came to the market with something that customers didn't want to consume. So we did our first ever customer advisory board or customer advisory group. So really we brought in 9 customers across our managed service provider and enterprise channel and just talked to them about kind of those same technology trends, what we were seeing, what we were thinking, and what we were kind of planning to do about it, but wanted to get their buy-in. And interestingly enough, there were obvious things that they were most concerned about, right? So price, performance, security, compliance, and the service level agreement that they've come to know from US Signal specifically. But most importantly is what they were not worried about or really interested in talking about at all, which is what we ran it on and what platform we used to deliver the product that they wanted to consume. So from the customer advisory board, we launched a research and development team that was kind of strategically built with members from the numerous technical teams that I've led in the past. And we put together this matrix you see here. So tabs across the bottom that you may not be able to see. This is just a snippet of the virtualization sheet specifically, but there was over 299 different data points specifically that we were looking at, and 5 different platforms that we went and got all of this data for to kind of make some initial decisions of what ones to even go to beta with or to even do any kind of functionality testing with. So we started with kind of that basic platform triage. We built this matrix, answered the questions, and got rid of a few options before we even got started, OpenStack being one of them. So based on that criterion testing, we decided to move forward with CloudStack from Apache, and we launched a customer beta in June of this year. So some of the same customers that we talked to in the customer advisory board, some additional customers opted in to test the platform for us and deliver a lot of good feedback. So that was pretty fruitful. Now, in terms of the evaluation process, so there's actually two different evaluations that were done, and I kind of already alluded to them. So first, we'll be going through a hypervisor comparison, where we're comparing OpenCloud, specifically CloudStack, against Nutanix and VMware for the enterprise look and feel of it, right? If you're a consumer of those, there'll be some metrics around that. And then secondly, we'll go through and compare, using pretty much the same metrics, compare OpenCloud to AWS, Azure, GCP, et cetera, et cetera. That's what I just talked about. Look at me, I'm ahead of the game. So these are, for some of these hyperscalers and some of these public clouds, there's not every single data point, and I'll explain why in just a minute, but everybody up here has some amount of data point that we'll go over. So the tool set for the hypervisor evaluation I was talking about is all open source. So we're leveraging Unix Bench to do some basic performance indicators, OpenSSL to do some encryption, decryption speeds, iPerf to do some east-west network testing between VMs across nodes, PG Bench to do some real basic database performance testing, and then FIO for storage testing. I feel like being at an open source conference, it would be silly for me to use all these open source tools and not at least try to shout out some of the authors, contributors, and maintainers. I will preventatively say if there's a name that is not up here that should be, you can come beat me up after this. I did my best to give as much credit as I could to the open source community. So if you've ever contributed to any of these tools or maintained it, thank you greatly. I used these tools to do my presentation and also to help make our decision for Apache CloudStack. And for the public hyperscaler evaluation, we used a company called Cloud Mercado. Should be noted, they're basically roughly using those same exact tools as well from an open source perspective. They actually have tons of data points that they maintain with those hyperscalers specifically. So if you're a service provider, you can use them to compare yourself to a lot of the data points they have. If you're a consumer, you can use them to look at a service provider like myself from a performance standpoint. They also factor the cost of the solution in. So while specifically I didn't call out cost in my title, there is a component of money in this, right? Like there is in every kind of open source conversation when you're talking enterprise and budgets and EBITDA and all the fun stuff that we all get to deal with on a day-to-day basis. All right, that was my lead up. Now we can start looking at graphs and numbers and all the stuff that hopefully you guys are here to see. If you're not here to see that, you should leave now, because that's all there is from now until the end is graphs. So first, we're going to look at the hypervisor comparisons. So here we're doing Unix Bench. On the right-hand side, those are all of the actual tests that are being run and some of the variables that we're using to run it. So we're predominantly looking at string handling, floating point operation efficiency, file transfer, process communication, and process creation. So the horizontal axis, since you maybe can't see the start of it, that is the number of operations it's able to compete in a specific amount of time. And we're doing this across the single thread and multi-thread. So it's basically deriving the score based on the number of operations divided by the time that it's running the test, right? So from Cloud Director, which is what we're using for multi-tenant cloud at US Signal, OpenCloud, Nutanix, you can see down on the right-hand side, I kind of summarized it as well, so we didn't have to go through every single data point. But OpenCloud and CloudStack is just shy of Nutanix on the Unix Bench compute. So the Unix Bench compute is not strictly CPU or strictly RAM. It's kind of an aggregated score. If we were to break it down, or you want to talk more about these afterwards, we can break it down. There's definitely some things it's better at, some things it's worse at, but on large, it's pretty close to Nutanix. You can see around 15% shy from the compute standard standpoint, but most importantly, 51% more performant than the VMware solution, which I think is pretty compelling, right? In subsequent graphs, we'll go over the same thing. This is one of the larger differences, I would say, from a compute standpoint specifically. So next up, we've got our encryption, decryption timing. So again, horizontal axis, we've got the number of decryptions that can occur in that amount of time. All these lovely colors up here are different block sizes or different encryption sizes. And then we've got Cloud Director, Open Cloud, and Nutanix. So again, barely shy of Nutanix from an encryption-decryption speed standpoint, right around 20% more performant than the VMware solution. Before we get into these graphs, just a little description of what we did from an FIO standpoint. So if you've ever used it before, you can really build these job files to do really, really specific things in terms of block sizes and queue depth, et cetera, to try to kind of recreate different things that you may see in the wild. So we came up with 5 different job files that we think pretty accurately represent a system not really doing anything, a system that's kind of busy, a contiguous operation, latency, et cetera, et cetera. So the title of each of the next slide will be the kind of data set that we used. On the right-hand side, some of the variables will be listed as well if you want to recreate the test or just know more about exactly the test that we ran to get the graphed results. So first up, we've got the 256K block size, random read-write, measuring throughput specifically. So how much data can be transferred to storage per second. We've got Cloud Director up top, Open Cloud in the middle, and Nutanix at the bottom. So this is one of the biggest numbers from, or a differentiation from the Nutanix perspective, is just how much more performant from a storage throughput perspective the Open Cloud CloudStack solution is over Nutanix, which was a little bit surprising to me considering it's HCI and a lot of the storage is local in how we've built it. I had assumed that would be a little bit closer. In this case, it's a little bit shy of our VMware Cloud Director solution, so about 5.8% less performant, but over 170% more performant from a storage standpoint than the Nutanix solution that we're comparing it against. And again, on the right-hand side, for all you nerds out there, I'm assuming there's at least a couple. Those are all the actual variables that we're using in the job file for the FIO test. Next up, very similar, larger block size. So 1 megabyte block size, random read-write, measuring throughput. So here we've got, on the right-hand side, you can see if you've got a photographic memory, and remember it was up there from the last slide. We've got a larger block size, smaller I/O depth, a larger amount of data being read and written in a single job. So we feel this is indicative of a contiguous operation, at least as much as we can recreate. Up top, you've got Cloud Director, Open Cloud in the middle, Nutanix at the bottom. So very, very similar to the Nutanix solution from a throughput perspective. Pretty largely more performant than the Cloud Director solution from a throughput perspective. 4K block size, random read-write, measuring I/O specifically. So here we're measuring the input-output specifically per second to see how quickly data can be written. So this is most indicative of a real-life scenario, as much as we can define anyway, right? What really is a real-life scenario? All of these could be very, very different, but this is kind of our baseline, if you were. So again, horizontal axis is your actual I/O. Vertical axis are the providers that we're looking at here. And we've got roughly 11% better than the Nutanix solution and 40% more performant than the VMware one, Cloud Director. 64K block size, random read-write, measuring I/O. Obviously, the block size is a little bit larger. We're doing four jobs per CPU and the queue depth of 16. So this is indicative of a busy system. Horizontal, vertical axes are identical from last time. And you can see 138% more performant than the Nutanix solution and 27% more performant than the Cloud Director solution. So safe to say it doesn't like the 64K block size at the very least. So this is our 4K block size read-write measuring latency specifically. So just a little bit of an idea on what the architecture actually looks like, just so you've got context. The Cloud Director solution is using spinning storage with a company called Infinidat. So we're doing fiber channel connected Infinidat storage. Those are all UCS M5, M6, B200 Cisco blades is what the Cloud Director environment looks like. The effectively, the open cloud solution that we're looking at here is kind of similar. So that's actually using Dell pizza boxes, right? 650 XSs. We're doing NFS connected storage there, and the InfiniNet that's connected to the open cloud solution is all flash, but still with InfiniNet. And then Nutanix, obviously, you've got your HCI. Those are HP. Those are HP Nutanix verified builds specifically using local storage. So one thing to call out with the open cloud solution, I feel like I need to call it out because I wasn't happy with how it graphed, is that the way that we've got storage set up from a DNS round robin perspective and the amount of network connectivity that's there, basically it's trying to push all of the write through a single connection. Once we get up to load a little bit, that number will probably drop down a little bit. I was just told I've got like 10 minutes and I've got a lot more graphs, so I'm gonna start flying. From an iPerf perspective, network east-west testing, I talked about this a little bit already, so basically testing between two VMs on two different nodes within the same zone or market. 33% better than the Nutanix solution, 32% better than the Cloud Director solution. PG Bench, again, this is exactly what we configured in the test for the slides that are coming up. Basically running the same sequence of SQL commands over and over again in concurrent database sessions, and then calculating the average transaction rate. 220% better than Nutanix from a database performance standpoint, and 40% better than Cloud Director from a transaction per second standpoint. Average latency, 68% better than Nutanix, and roughly 30% better than VMware from a transaction an average latency per that number of transactions. So we've got 50 client, 25 client, 10 client, and we're pushing 10,000 transactions through them at a time. Public cloud comparison. So again, I mentioned the company that we're using a lot of the same open source tools. These graphs will look very similar. They used better colors than I used in my graphs, so they're a little less assaulting to the eyes. There's not so much contrast, but we're talking about pretty much the same thing. So one of the things that is different is this spec score. So Cloud Mercado is taking all of the CPU and memory and storage and awarding a certain number of points based on how much you have in each of the instance sizes. So that's probably another thing that's important to call out with the next few graphs, is that we're actually going to be looking at 3 different instance sizes from US Signal, and those instance sizes really match the instance sizes of hyperscalers in public cloud. So they're different t-shirt sizes, but they're 8 CPU, 16 gigs of RAM, and then 832, 864, and in some cases 8 128 from a CPU to memory comparison standpoint. So you could see, or you'd be able to see if things were a little bit closer from an Amazon perspective, everything is kind of right in line because it's really just the amount of CPU and memory, and getting 1 point for each of those. Our Geekbench 6 general purpose node. So Geekbench 6, very similar to Unix Bench. It's doing a single score, which is CPU performance, and then a multi-score, which is whole system performance. So the darker color is the single score CPU performance specifically, and then the pale line is the kind of the multi-aspect performance, if you will, for the whole system. And you can see all the different public cloud providers that we're comparing ourselves against. Our compute optimized nodes, so this is heavy compute and light memory. The horizontal access and description for the single score versus multi-score is still relevant here, so you can see very similar to all the public clouds that we're comparing ourselves against, and same with the memory optimized. So same amount of cores, heavy memory, same comparisons being made to the same public cloud providers. Really happy with how this one turned out in terms of just being kind of right in the mix, right? And then the price per performance. So it's taking those performance metrics and averaging them out across those instance sizes, and then comparing those specifically to how much we charge for them versus how much the public cloud providers charge for them. the compelling story is just how big that graph is on the US signal side, right? To be completely frank, in terms of price per performance. So open SSL speed, so encryption, decryption times. I put all of the instances together, which I'm glad I did now that I've got 5.5 minutes to talk about some of these graphs, but you can see really the story here is just how similar to public cloud an open source solution can be, right, from a performance standpoint. Network latency on our general purpose nodes. So the best description I can give, if you can't obviously tell, is that like the more solid this line is and thick it looks, that's better, right? Because your latency isn't varying as much. So the thicker and smaller that line looks, you can see they're kind of drawing the best and worst case scenario and then averaging it out. The thicker that line is, kind of like the US signal one all the way down there, the better. So for our general purpose node, compute optimized node, and then our memory optimized node, from a network latency perspective, between two VMs that are on different nodes within the same solution, within the same zone, is phenomenal. I can't speak enough good things into the environment about Arista and their spine and leaf topology from a cloud networking standpoint. That's kind of what powers our network in the data center. From a network bandwidth perspective, so it's still doing the same test between nodes, but this one's looking at bandwidth specifically versus latency. So we're measuring between two identical machines, two different nodes within the same zone and market, specifically using IPv3 with TCP mode and a number of thread equal to CPU. And as you can see, higher is better if that wasn't obvious, but very similar to everybody we're stacking ourselves up against, similar or better, I should say. On the general purpose node, on the compute optimized node, same song and dance. Memory optimized node, same song and dance again, right? And that's kind of what we wanted to try to create when we came up with this offering, is really just something that could compete, that we had more flexibility with our price point to our customers around. From a storage standpoint, so here we're measuring IOPS specifically. I did pick out some specific numbers here because it doesn't tell you, you don't see the scale on this horizontal axis very well. So the US signal solution is about 16,000 IOPS. And the closest is obviously Amazon. They're within about 300 IOPS from our storage solution. But it's doing 4K blocks, random access, read-write, direct access to device without file systems, number of job equal to CPU. So they're using FIO as well, but those are kind of the parameters that they use specifically. And then the price per performance. So looking at the FIO graph that we just looked at and then comparing them against what we charge for storage in the open cloud solution versus what the the hyperscalers charge for their storage, the price per performance is clearly better. I had to shrink the graph because it was like oddly wide and there was a lot of white space on top and bottom. So that's even condensed to make it look prettier for presenting. If you see it in the wild, it's like a rocket ship to the moon, right, in terms of our price per performance. So very nice thing to see on our side of the house. Conclusion, I've got about 2 minutes left. I don't have any specific points to show you what I want to conclude, right? I think from somebody who's attending this talk, the conclusion is what you got from this that helps you make a better decision. A few things specifically to call out. From a hypervisor perspective, so looking at Nutanix and VMware, so OpenCloud built on Apache CloudStack compared to the most expensive options that you have in the market, it is just as performant, if not more performant, right? That's kind of the story to tell. And then from a hyperscaler standpoint, if you're looking to get out of hosting and hyperscale is your thing, right? Public cloud is your thing. Those graphs tell the same story, right? If you're looking to get out of infrastructure, come talk to me first, at least, because I can do it for cheaper and just as much performance. as the hyperscalers do. But I think most importantly, I've had a lot of good conversations with this community since being here for 2 days now. I think the real conclusion for me specifically in doing all the R&D, all the beta testing, all the research that we did, I never really looked at open cloud or open source software as anything more than like a bunch of cool tools and like little add-ons and bolt-ons and things that I could do to make my life marginally easier. And I think what has changed for me specifically, open source can be so much more than that. I think it just takes a lot of adoption in the enterprise and in the service provider space. And I think we're finally starting to see that a little bit. But really, it's everybody here, it's this community, it's the people who couldn't make it that you have back home that work with you that are really going to lift this thing up and I think make it more popular. This thing not being open cloud by US Signal, this thing being, CloudStack. Take the money that you save spending all that money on software with the hypervisors and just invest it in horsepower, right? From an infrastructure perspective, we heard from John this morning about investing in infrastructure. At the very least, you save a bunch of money on software, which you don't own anyway. Like, why spend that much money on something you can't own? Invest in people, invest it in training, invest it in contributing, and you'll be a lot better off effectively. Thanks.
Thank you, Daven, for nourishing our pride in our open source project.
Yeah, definitely.
We're a bit over time, but maybe there's one very interesting question. No? Wow.
My contact information is up there. Please reach out, LinkedIn, my email. I'll be here for the next 2 days as well. If you just want to tell me that I did something wrong or should have used different variables in my tests, I'm open to hear that as well. Looking forward to that conversation. I'll rerun the test and let you know what I find.
Thank you.